Wow. Well, thank you very much. I am honored to be here today, and I want to thank the Alibaba Group for inviting me to speak at this very important conference. You heard a lot about big data today. I'm going to talk about data for good. But a secondary title for my talk is Scary AI and Other Dangers with Big Data. So let me start by telling you what I mean by data for good. There are two parts to what I mean. One is using data responsibly, the responsible use of data. And the other is to use data to tackle societal grand challenges like energy and healthcare and environment and climate change and education. But today, I'm only going to talk about the responsible use of data, because all of us, of course, are using data for tackling societal grand challenges. The purpose of my talk today is to warn everyone about what can happen if you don't use data responsibly. I like to use this acronym, FATES, to tell you what I mean by responsible use of data. Fairness, accountability, transparency, ethics, and safety and security. It started out as an acronym, FACT, and then my friends at Microsoft New York City added an E, FATE, but I added the S, safety and security. And in my short time with you, I'm going to walk through examples of what I mean by each of these in my acronym. So let's start with fairness. Before I begin with my examples, let me just very briefly explain what I mean by the typical machine learning algorithm model that people use with big data as the input. So you feed data into an algorithm, a machine learning algorithm, and that trains a model. And with that model, I can put in new data, and that new data will tell me from that model whether it's a cat or not, or whether there's a prediction, like the user will click or the user intends to buy something. But what can go wrong? Well, what can go wrong is that the algorithm could be biased, or the data could be biased. And if the data is biased or the algorithm is biased, then certainly the model will be biased, and that means your outcome will be biased as well. So, let's look at an example. This was written in ProPublica a couple years ago, where judges around the United States use this particular algorithm to determine what the sentencing should be for a criminal. And it was turned out that proprietary algorithms, widely used by these judges, help determine the risk of reoffense almost twice as likely to mistakenly flag black defendants over white defendants. Now, you might think that this is actually unfair, but it's subtler than that, because when looking into what actually was going on in the algorithm, it was certainly biased. But it also turns out that some scholars from Cornell and Harvard discovered that a risk score can either be equally predictive or equally wrong, but not both. And what that means is that it's actually impossible to define a risk score to satisfy both notions of fairness. A second example was done by some of my colleagues at Carnegie Mellon, and they looked at Google and advertising. And they determined that in one particular case, high-paying jobs were shown more to men than to women. Another unfair situation. So we have to be careful when we use our machine learning algorithms and we feed it big data. Because how can we be sure that the models are fair and that the predictions are fair and the classifications are fair? Now this example raised another question of accountability. I mean, after all, who is to blame? Who was responsible for that discriminatory result? Was it Google? Was it the algorithm? Was it the advertiser? Was it the entire advertising ecosystem? Who's to blame? There's no good answer to that. But we have to be accountable. We in the IT industry, we who are inventing these algorithms and using these algorithms and using the models and using the data and generating the data and collecting the data and producing these outcomes. So if you're a company, if you are responsible, what can you do? Well, first, you can at least publish the policy, your privacy policy, for instance. You should comply with the policy that you promised your customers. And if the policy is violated, then you should fix your bug. So what I have done with some colleagues at Carnegie Mellon and also at Microsoft Research is look at an automated technique for showing how one can comply with a published privacy policy. And this technique, which uses off-the-shelf static analysis techniques from programming languages, we built into this tool called DataMap. And this DataMap tool is run at Microsoft nightly to detect policy violations. So this is something that automation can help when you're trying to actually be accountable for the policies that you publish. What about transparency? This is a big problem right now, especially when we're reliant on deep neural networks. So the question is, we are enamored with what deep neural networks can do for us today. But why should you trust the output? We don't even know why these DNNs work. They seem to do the right thing in practice, but from a scientific point of view, we have no idea of why they work. And this is what can go wrong. So before I get to the examples, let me just put in a little plug for the largest DNN that was ever built that ended up beating the ImageNet competition, which was this 152 layered deep neural network. And it was impressive at the time. It beat all the other competitors in this ImageNet competition. But it's kind of silly. Why 152? We don't know why. It just worked. To a scientist, that's not a good enough answer. So here are some examples of what can go wrong with DNNs. So here's an example. If I take a picture of a panda with a 57.7% confidence that it's a panda, and I mix in a little noise. And what do I get? I get that it's a gibbon with a higher percent confidence level. And you know what? A panda is a bear. A gibbon is a monkey. So something went very wrong with this deep neural network. Here's another example. This example shows why we need to be concerned when we're using deep neural networks to do image recognition. So this is a video where the car, you're driving in a car, and you see from afar a stop sign. On the right pane is ground truth. On the left pane is a stop sign with a little graffiti on it. You can't really see it, but there's a little graffiti on the stop sign. So the DNN recognizes correctly a stop sign in this video cut, and it thinks that stop sign with the graffiti on it is a speed limit sign. And as you're driving along, the video is going on at split second. The classifier actually recognizes that that stop sign with the graffiti on it is a stop sign. But then immediately, basically too late, it switches its mind and thinks, oh, it's a speed limit sign, therefore I'm not going to stop. And, well, there's where the crash happens. So it's not just pandas and monkeys and little examples that get you papers and conferences. This is potentially a danger if we don't pay attention to being responsible about our models and understanding how they work. And by the way, it's not just video. So in this example, the same audio is used to animate Barack Obama speaking that same audio track in 4 different ways. Now, this is just a humorous YouTube video that came out of a paper recently. But you can see how you can cross the line. And for any given audio stream, you can make anyone say anything. So you see the danger there. And this is not just a technology problem or something that academics like to write papers about. This is actually real for major companies like Alibaba that wants to work worldwide. So probably everyone here knows about EU GDPR, which is the global data protection regulation that the EU is putting out that all major companies need to abide by 2018, next year. And there are 4 pillars of privacy that they are requiring of all companies, and if you don't abide by these, you will be taxed or fined 4% of your revenue. So this is major, and every company that I know of is taking it quite seriously. So right to access, right to be forgotten, data portability, those are the ones that you would expect. But the one that is very surprising is right to explanation. Because you know what? We don't actually know how to give an explanation. So between now and 2018, the companies are scrambling to figure out how to give these explanations, and the scientists are actually trying to figure out how does deep learning actually work. Okay, ethics. So this is a canonical problem, the trolley car problem, which has been with us for ages, ever since trolley cars. And the question is, there's a switch person here, the trolley car is moving along, and the switch person has a choice. The upper track or the lower track? Do I let the trolley run over 1 person or 5 people? There's no good answer to this. And there are lots of variations. It could be a baby, it could be a fat person. There's just lots of variations to this ethical problem. Now, this is, you might just think it's another brain teaser. But in fact, today, with our self-driving cars, someone is going to have to make a decision. What should that car do when it's either sees a pedestrian right in front of the car, but there are people on the sidewalk? Does it run over the pedestrian or turn and run over the people on the sidewalk? There's no good answer to that. But someone who's coding that car is going to make a decision. And this sort of fake news problem that is really hitting the United States hard right now is another ethical problem in terms of misinformation and propaganda. The one I thought I would share with you is something that relates to China a little bit more. It is a Microsoft example. It's Xiaoice. Xiaoice is used, very popular here in China as a chatbot. It was so popular that we in the United States felt a bit envious that the Chinese had this chatbot and we didn't have an English counterpart. So of course we created one at Microsoft last year called Tay, and we released it on March 23rd, 2016. And within 24 hours we had to shut it down because the underworld of the internet discovered it and made Tay say some inappropriate, highly offensive, just bad remarks. And it's not that Microsoft didn't go through an ethical review board. We just didn't realize how quickly and how nasty these internet trolls can be. So we learned a lesson from that, and that is to take ethics very seriously from the beginning, when you're designing the technology, not after you deploy it. My last example is safety and security. We have lots and lots of devices. You have to pretend this is Tian Mao Jingling, okay? The idea here is any of these devices in your home, driving around, can be hacked easily. This is the cybersecurity threat. There are new IoT platforms out there. Anything connected to the internet is potentially a new attack vector for the bad guys. And so you need to take this into consideration, privacy and security. And of course, if you have drones flying around, you want to make sure that those drones aren't going to hit people or cause any damage. So let me stop and just remind you of my acronym: FATES: fairness, accountability, transparency, ethics, safety, and security. And more broadly, what can technologists do to try to help in this direction? Well, working backwards, first, rather than just output "it's a cat" or "the user is going to click here," we should be outputting probabilities or the distributions. And we should publish our algorithms and models and their parameters so others can check our work. And it's true, big companies are not going to give away their assets, which is the data. But we can at least provide individuals that we collect data about, we can provide those individuals their data. And I wrote a paper with two colleagues of mine called Inverse Privacy that you can read that changes the equation about who has data about you. So let me just say that the technology companies some of them are taking responsibility about trying to make sure that we use data for good, that we use AI for good. And just last year, a partnership on AI was created with the founding members of Amazon, DeepMind, Facebook, Google, Microsoft, and IBM, and Apple joined in January. And now many other nonprofits and government institutions are joining in this message that AI can be used for good. AI can be used to benefit society, but we in the technology industry have to take that responsibility to make sure that we do so. So, this does raise new questions. Do we need laws of artificial intelligence? Isaac Asimov had 3 laws of robotics. Do we need to revisit those laws for AI? Should AI be regulated? This is a debate that we are having in the United States now. Should the platforms and pipes that use AI be regulated? If so, by whom? Do we need consumer protection, insurance, or economic incentives against bad AI? Do we look for some kind of AI product of seal of approval, the way we have for consumer protection? And should companies be required to have an institutional review board for AI or big data? So these are new kinds of questions that I'm posing to all of you. Let me stop and just remind you that data for good is not just about responsible use of data, but tackling societal grand challenges with big data. Thank you very much.